Hey guys, I'm back for discussion question 2. So the question is to describe a scenario where the median values of a data set differ significantly and what insights can be gained from this difference. This is a SpaceX data set. I was actually going to use this on my topic 1 and topic 2, but I found it way too interesting and there were no outliers anyway, so we're just going to discuss this one for topic 2. For real world examples, you can look at economic studies. Wealth distribution has a huge variability. Real estate, housing markets, they obviously have huge variability. It goes a lot along with wealth, right? Internet traffic, though, that one I always find really interesting because you're going to have higher traffic on certain days, like a release of a new Stanley tumbler, right? Everybody's obsessed with those right now. So I guarantee you when they release a new tumbler, they have way more traffic than they're used to. Stuff like that. So a skewed distribution is a significant difference between the mean and the median. Solutions for this discrepancy, you can use median for central tendency. The median usually provides a better measure because it's less affected by those extreme values like we discussed in the outliers discussion. You can apply a log transformation. You can use a trimmed mean, which is like the IQR, and then do the mean, or a robust statistical method, which there are tons of, like MAD or the median absolute distribution, like I use in this video. So here we are, we're pulling in the data set. When I pulled in this data set, I realized some of these are not numbers. So I had to create a little code so that I could see, which ones are numbers and which ones are not. And the ones that are numbers, I put in a list and then output them. And some of them were blank. So we had some nans. And so then I had to clean that up, clean out the nans, get rid of those. And then I wanted to see if we had any outliers. Like I said, I almost used this one for the first discussion, but then I didn't. So I did the outliers anyway. When we do the outliers, there are none. I checked it twice, 2 different ways. So then here we have our box plot. Something I noticed about the box plot is that it's really, really big. And so when I found that out, I was like, well, that's weird. And then I did the measures of central tendency and found the mean and the median to be nothing alike, which is why it ended up in discussion 2. So that is a huge difference. This is a very large amount here, and with none of those being outliers, it kind of makes you curious. So when I kept going, I decided to make a density plot, and we can see here that there are 2 very large humps. So our data for an average weight or an average payload mass, or a median even, is going to be really skewed. Right here, I think this is a negative skew. I wrote it down. I'm still working on remembering which one's negative and which one's positive. So if it's right skewed, if it's right skewed, it would be larger on the right. Or a positive skew, it's larger on the right. If it's negative skewed, it's larger on the left. So this is a negative skew. If I were wiser and had more data, as a data analyst, I would absolutely not just look at this and be like, oh yeah, let's find the average. I would say, okay, something's going on here. What's the difference between these 2 groups? And try to figure out what the difference is between those 2 groups. My assumption, based on the dataset's name, is I would say one of these is a Falcon Heavy spacecraft and one is a SpaceX. Excuse me. Or Falcon 9. I'd have to look at the title again. One's Falcon 9 and one's Falcon Heavy. That would be my assumption. However, they didn't give me that in the data. They didn't specify which one was which. They just gave me all of them with the payload masses. So if we want to find a median payload mass, we're going to have to do some more math. Very interesting. So the first peak here, like it says, is around 5,000, and the next one's 15,000. That's a pretty big difference. So I applied a log transformation first, and I wanted to look at the old versus the new. So I pulled in both. So here we do the natural log transformation, and we can see how we go from the jumbled mess on the left to a more easily readable graph on the right. So you can definitely tell that there's a skewed distribution here. And then the log transform data shows us a more symmetrical distribution. And it's definitely going to be easier for an analyst to look at that one on the left. So then if we do a median absolute deviation. I thought it was distribution. Oh my gosh, I'm using the word distribution too much. So it's one of those robust statistical methods. And it's really useful in situations where data doesn't follow a normal distribution, or like previously we have a bunch of outliers. So here you can see that our median absolute deviation is somewhere around 3,900. But so that's that. Thanks for tuning in. Sorry, this got a little long.